December 12, 2025, a robotic telescope in Ireland is scanning the moon when something extraordinary happens. A flash erupts from the lunar surface, bright enough to be seen from 240,000 miles away. For less than a second, a point of light appears where there should only be darkness. We just caught a lunar impact live, and watching it happen in real time is genuinely unsettling, not because Earth is in danger, but because of what it reveals about the neighborhood we are living in. The flash appeared near Langrenus crater on the moon's eastern side. It lasted less than a second. A brief burst of light that would have been easy to miss. But it was bright enough to tell us something significant about the energy released. The object wasn't large. Based on the flash, researchers estimate it was roughly golf ball sized, perhaps 3 to 5 centimeters in diameter. But here's where intuition fails. Size matters far less than speed. This fragment was moving at 35 kilometers per second. That's 78,000 miles per hour. At that velocity, even a golf ball-sized object carries the kinetic energy of a small explosive. The timing wasn't random. Earth and the moon were passing through debris from 3200 Phaethon, a 5.8 kilometer wide rock that follows a brutal orbit, diving closer to the sun than almost any other asteroid. As it repeatedly endures these solar approaches, its surface cracks and shatters under thermal stress. Every December we cross this trail, creating the Geminid meteor shower. What we saw on December 12th was the moon driving through that same debris field. There's something deeply uncomfortable about watching an impact happen in real time. When we see photos of craters, the violence is buried in deep time. It happened millions of years ago. This was different. This was violence in the present tense, visible across 250,000 miles of space. A fragment that had been silently drifting suddenly ceased to exist, converted in a fraction of a second into heat, light, and vaporized lunar dust. The entire event unfolded without sound, without warning, and without any possibility of intervention. The unsettling part isn't danger. Earth wasn't at risk. The unsettling part is scale. Out there, beyond our atmosphere, things moving fast enough become destructive forces, and they strike without announcement. Let's talk about what actually happened. At 35 kilometers per second, 35 times faster than a rifle bullet, kinetic energy stops behaving the way we expect. When you're dealing with speeds like that, doubling velocity doesn't just get double the energy, it quadruples it. The moon has no atmosphere to slow incoming objects. Every fragment, no matter how small, reaches the surface at full velocity. When this meteoroid struck, it didn't bounce or shatter. Instead, the kinetic energy is converted almost instantaneously into heat. The rock and the surface material it struck were vaporized, transformed from solid matter into superheated plasma in less than a millisecond. Plasma is matter heated until atoms break apart. For an incredibly brief moment, the impact site reached temperatures comparable to the surface of the sun. Not from combustion, there's no oxygen on the moon, but from pure thermal energy. This is why the flash was visible from Earth. The event was small, the resulting crater probably less than a meter across, but the brightness of the plasma made it detectable across interplanetary distance. And it all happened in total, crushing silence. The moon is probably hit by objects large enough to produce visible flashes several times per month. Current monitoring data shows dozens of impacts detected each year. So why don't we see them constantly? Timing. For an impact to be recorded, several things must align. The moon must be in the right phase. A telescope must be pointed at the right location. And the impact must occur during observation. Most impacts go unrecorded, simply because no one is looking at the right place at the right time. The December 12th event wasn't unusual in a physical sense. Impacts like this happen regularly. What made it notable was clear documentation during a known meteor shower by equipment designed to detect such events. The physics is routine. The documentation is rare. Should we be worried? No, but the answer is interesting. Earth moves through the same debris fields as the moon. During the Geminids, both bodies are exposed to the same fragments, but Earth has an atmosphere. When a meteoroid enters our atmosphere, friction generates heat at altitudes between 70 and 100 kilometers. For small objects, golf ball-sized or smaller, the heat completely vaporizes them before they reach the ground. What we see is a meteor, a brief streak of light that burns out harmlessly. The object that created the flash near Langrenus would have produced a typical shooting star over Earth. Bright perhaps, but gone within seconds, leaving nothing behind. No impact, no crater, no danger. This doesn't mean Earth is immune to impacts. Larger objects can survive atmospheric entry, and over geological timescales, Earth has been struck by asteroids large enough to cause significant effects. But these events are rare, measured in timescales of thousands to millions of years. And current detection programs work to identify potentially hazardous objects decades in advance. The December 12th impact was a single event among countless others occurring across the solar system every day. What made it significant wasn't the physics. That's been understood for decades. What made it significant was observation. The footage has scientific value. It contributes to research into impact rates and near-Earth object populations, but it also shows us directly and unambiguously that space is not a backdrop. It's an active environment where things are constantly happening, most of which we never see. We live in a time when telescopes can capture events that would go entirely unnoticed a generation ago. The fact that we can watch a lunar impact unfold in real time reflects how far observational astronomy has come. And as monitoring programs expand, we'll document more of these events, each one adding to our understanding. The flash near Langrenus lasted less than a second, but the data it provided and the conversations it sparked will persist much longer. That's why observation matters, not because the universe is dangerous, but because it's knowable, and knowing it changes how we see our place within it. If this look at the December 12th impact gave you a new perspective, there's more to explore. Lunar monitoring programs continue to watch, and each meteor shower brings new opportunities for observation. Subscribe to stay updated on discoveries like this, and until next time, keep looking up. The universe has a way of surprising us when we pay attention.